final question in your quiz was to write a piecewise function for the graph that I gave you. What I did is I broke it up into boundary regions again, intervals, and I color-coded them so that you could see the three pieces. And I would break this up into smaller little parts so it's not so hard to digest. This first part that I'm showing you in the blue, it's only going to have an impact on any of your x values that are less than a -2. It's the open circle here that I'm going to clue in on, and it's going all the way to the left. So all the way left means it's going to a negative infinity. So it's saying this part of your graph is good only when your x values are less than a -2. And less than -2 means everything to the left of -2. The second part of your graph, the interval that I want to describe, is this one that's in red. Well, the interval starts at a -2, and it's a solid circle, so I get to use the -2, and it goes to a +2, so I get to use that +2. So we want every x value that's in between a -2 and 2. The simplest way of writing that statement is if you want all the values in between a -2 and 2 is -2 is less than or equal to x, which is less than or equal to 2. That tells me all the values in between there. The third interval starts at a 2, but doesn't get to include it because it's open and then goes on forever or towards positive infinity. So that means we can use any x value that is greater than 2. So I would say the first thing you want to do is break it into the smaller steps. Identify the intervals for your three different pieces. Okay, so now we have that finished. Now let's go work on the equations. The equations, since all of these are lines or linear, we can fit them into the y equals mx plus b form, and that's what I was expecting that you would put your lines in slope-intercept form. This first part that's in blue, that is a line that has a slope of 0, so y equals, the slope is 0, horizontal lines have that type of a slope, times x plus b. And now the b can be found by simply extending this line out, and where would it cross? It would cross at a +1. So it's really 0 plus 1, or y is just equal to 1. It's a horizontal line, and horizontal lines can always be graphed by a constant. It's our constant function, and that says our f of x is 1. That's all I need for it. So now I'm going to look at the second question. So the second part or interval, which I highlighted in red, it has two ordered pairs here, and two ordered pairs we can use to find the equation of the line. But one of the things I want to know is the y-intercept. What's convenient about this one, it shows us exactly where it crosses. It crosses at 3, so it's plus 3. The other thing that we need for the equation of a line is a slope. So I'm going to look at going from this point here down to this point there to calculate my slope. As long as I know two good points that it crosses through, I can determine that. So I got to go down 1, which is -1, then I got to go right 1, 2. That's plus 2. So our slope is y equals a -1/2 x. So that's our second piece to our equation. So that is a -1/2 x plus 3. And you can pick other points on it just to illustrate that it doesn't matter. I could have chosen this point, go down 1, go right 1, 2, and you get the same place. So having your slope and y-intercept. Now I'm going to go to the third one. The third piece that is in green, I can't determine exactly where it is for y-intercept at this point, but what I can do is I can figure out the slope. And what I'm going to do is grab this slope right away. So it starts here. Now I'm going to see if I can find a place where it goes right back through an ordered pair again, or right through a grid, and it's right here. That's the intersection of the horizontal, vertical and horizontal. So what do I have to do to get there? I have to go right 1 and then up 1, 2. So right 1 is plus 1. A better color, plus 1, and up 2 is plus 2. So it's always rise over run, or change in y over change of x. So that means it's a slope of 2 over 1 x. Then I got to go plus b. And I probably want to rewrite that as just 2x plus b. Now we want to figure out where it crosses the y-axis. So one of the things that you could do is try to figure out if I extend this line downward, where it's going to cross through. The other thing that you can do is you can use your slope. So let me show you kind of the visual way. If you take this line and you map it up perfectly with it, where does it cross through? So I don't have quite on that line, but it looks like if I do this and extend it with my pencil and paper, I can get it to cross through -1. Now let's see if I can do this graphically and show you how you can also trace it with your slope. We've already determined the slope is up to right 1. So well, you can also go down 1, 2, and then left 1. I didn't hit the x-axis or the y-axis yet, so I go down 1, 2 with my slope, and go left 1, and there I am hitting the y-axis. So the final version of this is going to be y equals 2x. Our slope was 2. We found out that it crossed the y-axis at a -1, so it's just 2x minus 1. So this is our final piece, 2x minus 1. So that is an example of writing the piecewise function if you're given the graph.